This is Dr. Holt. In this video, I have a man that's pulling up on a cable that goes around a pulley and then is attached to a 20 kilogram block. What we want to do here is we want to determine what the force is in AC, AD, and then AB, this rod here. Alright, again, what I would do at this point would be draw myself a free body diagram at the intersection point here. Now I'm going to have this force AB going off here. Now if you want, you're welcome to move it like that. I prefer to show it from all the tails coming out from the origin. Now I established the origin at this point here. This line right here dotted is going to be parallel to the z-axis here. This line dotted is parallel to the x-axis here, and this line here is going to be parallel to my y-axis. Alright, again, it's not that important that you get the direction right, but whatever way you establish that direction, then keep it that way when you set up all your components. Alright, once you have that free body diagram set, the next thing to do is determine what the length of each one of these cables would be. And from here, this cable is going to go from A all the way down to this point right here. So I went ahead and established that. And I did that through Pythagorean theorem. Well, I call it three-dimensional Pythagorean theorem, but I have a vector that is three-dimensional. So, for example, let's talk about how to get the length here. I'm going to go down 6 here, and then from this origin point, I'm going to go over 7 here, and I'm going to go back 6 here. So let's just set this up. So I'm starting from here. How far do I go in the x direction? I go 6. So I do 6 squared. How far do I go in the y direction? Well, from here I'm going to go down 6. So 6. So now I got 6 squared. So 6 squared plus 6 squared. And then the other dimension, how far do I go in the z? I do 7. So 7 squared. So I got 6 squared plus 6 squared plus 7 squared. I take the square root of that. That'll give me the value of 11. Now I do it from this vector here. Now note, this vector is not 6 long. This vector is going to be 4.5 here and 6 here. This vector is only in 2 dimensions, so I'll do 6 squared plus 4.5 squared. I'll take the square root of that. That'll give me a vector of 7.5. Again, I do the same thing for AC. I determine what the length of that is. And I did it for AB also. And AB is a little simpler. I guess it is a three-dimensional vector. I got 3 here, I have 6 here, and I have 6 coming down here. I established that as 9. So those are my lengths that I have. And what you're going to do at this point is basically you're going to be using the cosine for everything. So I'm going to say I'm going to summation the forces in the x direction. I'm going to take the x direction. I know everything has to equal 0 because this system is not going to accelerate along the x-axis. So I come to the first one, I take 6 divided by 7.5 times 196. And where I get that is if this force here, which is the mass, 20 times 9.8 coming down here, if that's 196, since it wraps around a pulley, and the pulley has no mass, we're making the assumption the pulley has no mass, then this force has to be 196. So I take 196 times the length of how far I'm going to go in the x-axis, which is 6. I divide it by the length of the vector itself, and that's 7.5. And that's where the 6 over 7.5. I multiply it times that force. I make it positive. I make it positive because the x component of this is going to be positive. I come to AD. My AD vector here is going to be going 6 here in the negative direction, so I make negative 6. I divide it by the length of 11, and I multiply it by AD. I do the same thing for AB. AB vector is this way. I got it coming out this way. It's going to have a positive x value. So from here to here is 6. So I take 6. I divide it by the length, which we said was 9, and multiply it by AB. I come to this one. It's going in the negative direction. And how far is it going to be going? It's going to go 6, and then it's going to go another 4.5. So 6 plus 4.5 gives me the negative 10.5. I divide it by its length, which is 14.5, and I multiply that by AC and set that equal to 0. So that's one equation. I do the same thing for Fy. Again, I'm probably not going to go through every one of these, but you can look at the picture. Here I got 4.5. The reason I got that, I'm coming down 4.5. I'm going in the negative y direction, so I make it negative 4.5 divided by the length of this. And again, I multiply it by 196 because we know the force in here is 196. I come to AD. The AD vector is going to be this one here. How far am I going down in the y? I'm going 6. So negative 6 divided by the length times AD. I come to AB, and the reason I make this positive is only because I'm showing AB going back up. You could have the vector going back down and get negative, but then when you set up your matrices, you're going to find out you're going to get a negative value for AB, which means it means it's going back in the opposite direction. So AB, I'm going to go up 6. I take 6, I divide it by the length of 9, and that's where this is coming from, AB. I go to AC, my vector right here. I'm going down 6. So I take negative 6, I divide it by the length 14.5 times AC, and the only other one I have is this one, minus 196. I do the same thing for Z. Now, the reason AE, it has no Z component, so I put a 0 right there. I come to AD. AD, how far am I going in the Z? I'm going 7. Take 7 divided by 11, and I'm going positive, so I make it positive here and multiply it by AD. I go to the AB vector. AB vector is right here. How far am I going in the Z direction? Since this is where I'm starting from, I'm going, as I move up here, I'm moving 3 in the positive Z. So I take 3, I divide it by the length of 9, and I multiply that by AB. And then AC. AC vector is this way. I'm moving from the origin all the way back 8, so I'm going negative. I'm going in the negative Z direction. I divide it by 14.5, and that's where this value is. And again, set this equal to 0. At this point, I set up a matrices. Now I'm going to move everything that does not have a variable to the right side. I set up this column as my AD column, this is my AB column, this is my AC column, and this is the value. This is everything that's on the right side of the equal sign. So in this equation here, I add this value and this value together, and then move it to the right side, and that's where the positive comes from here. This value here, since it's positive, I move it to the right side, and that's why I get negative here. And then all you have is a nice matrices. You have a 3 by 4. You have 3 rows, 4 columns. Just do a reduced row echelon and solve this problem, and when you do, you will get these following values: 1740.5, 1550.7, and 402.5. Again, if you establish this one going the opposite direction, then what would happen in your matrices, you will get a minus 1740. And that's the only difference. Okay, I know this video is very short and kind of to the point. It's a problem we worked in class today, but I hope it explains how to set up these vectors. All right, best of luck.